Alright, final subtopic for this chapter is on period of SHM. So in this subtopic, you have to be able to use the expression for period of SHM only for the situation of simple pendulum and single spring lah. Okay, so this one is the derivation part. So basically this one is for simple pendulum. So let's look at diagram A. So a bob of mass M here is attached to a retort stand with a string length of L. So this is known as the equilibrium position. It does not move lah. Okay, so V is equal to 0 at this point. Right, so and then at this diagram B, the bob is displaced to point A and then released. Okay, so this release of the this will cause the bob to oscillate from A and then goes to B, and then from B goes to A. Okay, so it swings back and forth lah along a circular arc. Here we can let's just say it is between point A and B lah. So this point A and B is actually known as the amplitude. Okay, so this this one. So it is actually this one, start from equilibrium position to this point. Okay, so this is known as the amplitude. Okay, alright, lepas tu and let's look at diagram C. So diagram C is basically the free body diagram lah, timed at point A di sini. Okay, so for an oscillation with very small amplitude, we can assume the bob moves back and forth along the x-axis lah. So the vertical motion sekarang ni kita ignore sebab the acceleration in the y component is very small. So basically we are only focusing on the x component. Okay, so we can let the y component, the forces at y component is equal to 0, which will then gives us the tension to be equal to mg. Okay, so T equal to mg. And then yang cos theta dia ni hilang sebab it is a very small angle, so kita boleh just let it equal to cos theta equal to 1 lah, meaning we can actually ignore it lah. Okay, so and then the weight of the bob has no x component, so the only force present is the restoring force due to the strength, which is equal to this lah. Okay, so we know that the restoring force is directly proportional to the displacement, so we can then let this equation to be this one. Okay, so if we want to find the angular frequency, we know that A is equal to negative omega square x. So from here we can then actually see that the omega, which is this one, if we compare, this is ax negative omega square equal to x, where omega square is actually g over L. Okay, so ini dah just compare the general equation with this equation. Okay, so the angular frequency for simple pendulum, untuk simple pendulum, is this one lah. Okay, so the period after rearrangement is equal to this untuk simple pendulum. Okay, right, and then lastly for single horizontal spring, so let's look at diagram A. So this one is the spring is at a relaxed position which has a spring constant of K, and it has 0 mass. So the spring is fixed at one end, which is at this part here, and the other end is attached to this ball with mass M. So this is a frictionless surface. So at this point, this is the equilibrium position. So at this point, the net force is equal to 0. Okay, so assuming the object is pulled to point A here and then released, it will produce a restoring force. Okay, so if the motion is going to the right, the force that is trying to restore the spring to its original position will act to the left. Kenapa? Sebab dia mau try untuk get the spring back to its equilibrium point, which is at this point here. Okay, right, so when it is pulled and then released, the object again will move back and forth begitu. Okay, so that is along a straight line between point A here and then point B here. Okay, so again, both of these points are known as amplitude, which is from here until from here to here. So this is the amplitude. Okay, right. Lepas tu, let's look at point B. Again, this is just the free body diagram of the spring. What is it is experiencing during the motion. Okay, so the normal force is equal and opposite to the weight of the object. So we can then let the normal force to be equal to the weight of the object and equal to mg. And then as the object moves to the right here, the restoring force is the spring force lah, which is equal to kx, negative kx. Okay, and then since the spring is actually equal to the restoring force punya force, we can actually let it equal to this. Okay, so again, compare it with the general equation for acceleration. We can then say that the omega is equal to the square root of k over m. Okay, so square root tu dapat dari yang ini ya. Okay, sekarang ni omega square equal to k over m. So omega saja, it is the square root of k over m lah. Macam tu lah, jangan confuse. Okay, so basically the period for a single horizontal spring is this equation here. So the period for the single horizontal spring depends on both mass of the object and then the spring constant of the spring. Okay, so that is basically the theory part for example subtopic 9.3.